Okay, there we go. Yeah, so objects. And I think last Friday I went over like the beginning part of this. Okay, let's keep it quiet. We went over the beginning part of this where we introduced introduced isn't the right word, where we talked about the differences between methods and functions, right? And attributes and variables. But a method is like a function that belongs to a specific individual object. So if we have two lists, and I say append to the list labeled list 1, if I say append, well, I'm using the method append, but for list 1. And if I use append on list 2, well, then I'm using that method that lists can do, but it belongs to, like I'm doing it on list 2. Similarly, like length. Let's pretend length is an attribute. Every list has a length, right? But if I ask list 1 what its length is versus list 2 what its length is, they might be the same, but they might be different. They don't need to be the same, but they both have the attribute length. Just like everyone in here, you all have a first name attribute. You all have a first name. I could ask anybody what their first name is, and they have an answer. But the value of first name between each and every one of you is likely different, but that doesn't matter. You all still have a first name. And we like to talk about, we went over this, right, where we talked about, remember, yeah? Yeah, well, neither do I. And you know, we do this to emphasize like abstraction. I know we talk about this a lot, but this is a big thing where, you know, I've got a car, but I don't want to worry about all the inner workings of the car. I don't care. I just want to be able to use the car to do what I need to do. By layering things in layers of abstraction, objects help facilitate that, and we like that. All right. So Numpy arrays, yeah, we did this. The point is, okay. Now I think it's coming back to me. This is, I think, right where we stopped. So easiest thing to do is to start by making an object. All objects belong to a class. A class is the definition of what it means to be the specific object. We are going to make an enthusiastic student object. So I'm writing the enthusiastic student class. This is where it defines, it's like a blueprint. This is where it defines everything about that, like for those objects. Every object that's created, every time I make an enthusiastic student, or every time you made a list or a Numpy array or anything, it went and it checked out the class for that object to know, like, okay, well, what's there? What do I need? Within this class is where we define things like its attributes and its methods and whatnot. So I want to make an enthusiastic student object. So to make the analogy here, raise your hand if you've used Numpy array at any point yet. Okay, about half of you. I mean, we've seen it. Someone wrote the code to define what a Numpy array is. Someone wrote that class. And it's a pretty general purpose, really handy one, so everyone uses it. Now, we are going to write a program that needs enthusiastic student objects for whatever reason. Not very general purpose, but we need it for our reasons. So I'm going to write the enthusiastic student class. Typically, we're going to need 3 main things within our class. This is speaking very generally. Technically, I could say 2, because 1 is another one. But we're going to want a constructor, which is just a method, but it's a special method. We're going to want the methods, and we're going to want the attributes. Sometimes you'll hear people say attribute, field, property. They all more or less mean the same thing. It's kind of programming language dependent on what the conventions are. But that's like the variable that belongs to that specific instance of an object. Then there's the methods. Those are the things that we can have the objects do. And the constructor is a special method that gets used when creating the object. Remember how for Numpy array, you had to say like, hey, Numpy array, and then you put in the parentheses what you wanted in that array. That's calling the constructor for Numpy arrays. And within the constructor contains all of the information, all of the code needed to do any setup that's required. Sometimes very little is needed, sometimes a lot's needed. But in addition, like Python or whatever programming language we're making an object, we'll do a lot of back-end stuff too to set up and like put the object somewhere in memory to keep track of all that bookkeeping as well. But at this stage, we like to think about it as the constructor just defines like the starting conditions. And then it exists, and then you can do whatever you want with it once it exists. So we can ask ourselves, what attributes do we want? Let's focus with attributes first. I want to make an enthusiastic student object. Which attributes could we give this class? At this point, we're making this up ourselves. We can put whatever the hell we want in there. First name, last name, student number, currently average. That should be current average. Oh, by the way, who was the one that made the pull request on GitHub? Nice, well done, well done. We've got our first, he's the first one. We should have a competition. Whoever contributes the most at the end of the semester wins, I don't know, a pat on the back. So there's a bug someone can go fix real quick. See the typo, currently average? It should be current average, so FYI. Anyways. We can have whatever else we want as an attribute. Literally anything that we could store in a variable we could put there. Hair color, eye color, height, age, shoe size, favorite color, whatever. We can put whatever we want there. Some of those might not be overly relevant for what we need, but we can do whatever we want. We get to make it up. And what methods might we want to have for this class as well? What do we want to be able to do with this object? At this point, the object we're creating is very deliberately designed to show you how you do it. There's no real good reason for its existence. On the assignment, you'll be making like country objects that hold on to special information for you. There's more of a purpose behind it because there's like a goal. Here it's just demonstrating, it's very contrived. But what do we want to be able to do? Well, we can have students ask for a higher grade, show off in class how smart they are. This is my favorite one. Work painfully hard on assignments like you all do, right? And oh, here's another typo, I guess. There. So these are all the things we want to be able to have the student object do. And we can write whatever other methods we want. We can do whatever. But these are the ones I'm going to have. Just because. Yeah. It's not even, what you're saying might be correct, but I'm just going to say it with better words. The class is the definition. It's like the blueprint of, if someone wants to come along and actually create an instance of an enthusiastic student, the class definition is the blueprint on how to do it. So it's basically, here's all the information you need to know to make one. And then once one exists, it's in RAM somewhere that we can go play with. That is kind of what you meant though, right, I think? Okay, raise your hand if you've switched to using PyCharm. No one? All right, that's fine. If you have, typically if you're doing classes, typically is not really the right. It would be very common to have all of your classes in separate files. Just FYI. So, here's what we're going to do. I'm going to open up PyCharm, or not PyCharm. Oh, look at that. A3 cheaters. They're all right here. So, I'm going to start writing this class. It's going to be easier. I'm going to recommend you put all of the class in one cell on Colab. I don't even know if you can do it another way, but do it in one big cell. We start, and here's the code. I'm just going to copy this, copy, paste. There. This is the starting of my class. I say class, name of the class that I want. I'm calling it enthusiastic student. And notice the naming, how it starts with an uppercase, FYI. But there's nothing inside of it yet. But the only important stuff here really so far, because there's a bunch of comments. In this, I'll get rid of this comment, not that useful. Class, enthusiastic student, colon. So class is the special keyword. Enthusiastic student, that's the name of the class that I'm creating. I can call this whatever I want. I can call it boop for all I care. And then a colon. And then everything that I want to be in this class, a part of this class is going to be indented, like everything else. I'm going to get rid of this comment just for readability. But there, this is the start. Now, of course, if I run this, nothing really is going to happen because I haven't said anything. It's going to probably even tell me that we got an issue with end of file. So there's nothing there yet, but I've started writing my class. This is basically getting to the stage of, okay, class this, indent, all right, now I'm ready to start. This would be similar to def, my function name, parentheses, colon, and then inside of it, I'm going to start to what's in that function. Here, what's in that class. So there we go. This tells Python, hey, everything that follows is going to be part of the enthusiastic student. Classes do not need to be in their own files, but it's often a good call to do so. All right. That's relevant if you're using PyCharm or Spider or something. So next, we'll write a constructor. This is a method, but it's a special method that just sets everything up. It'll create it'll like maybe set attributes, maybe run some extra code that needs to be done for some, I don't know, pre-processing, whatever. It could be whatever we want. This is going to be a very simple one, but it's not uncommon to have very simple classes for just storing data in a certain way and to be able to interact with it in a special, well-defined way. A lot of this, so let me hit pause on this discussion on classes. You may have noticed, and I usually have this conversation earlier in the semester, you may have noticed that Python is a real deal programming language, okay? It's not a programming language designed for you to learn to program. We're using it to learn to program. But you got to remember that the people that design Python or any of these other big programming languages, they designed it because they knew what they were like engineers and programmers that knew what they wanted to do, and they made it so they could do those things. And as a consequence of this, when you start to learn programming and everything, there's not a nice, easy path from beginning to end. Up until a certain point, like, okay, we learn printing stuff out, reading input, variables, functions, loops, ifs. You know, there's this progression. But then we get to this part where, well, I'm going to explain this to you, but that's not going to make sense until we cover this topic, but I can't cover that topic until we cover this topic, but that topic has to come after that. So we end up in this funny little web of like, okay, here's something, just go with me on it. It's going to make more sense a little bit later. You're going to have to put a little bit of faith in me and trust me, because once we start talking about classes, it shouldn't be too bad in throwing you off, but there might be some stuff of like, wait, what? That will kind of come together soon. So if at any point you're feeling very, very, very lost, there's a good chance that it's just because this is a brand new, pretty big, beefy concept that has a lot to it before it'll all kind of full circle come together. Yeah?
Do all programming or all the major programming languages use classes and all that?
No. So object-oriented programming languages do. So they're called like object-oriented. Most of the really big popular ones today are object-oriented. But they don't have to be. Like C. Not C++, C doesn't have objects. It's just programming procedurally. Yeah. But your languages like Java has objects. Python has objects. C# has objects. C++ has objects. A lot of them have objects because they're just really handy. But in a lot of languages too, like in Python, you can go ahead and never write your own objects. It doesn't really matter. Now, in some languages like Java, everything has to actually be a part of a class. I mean, you can write it in a way where it's not, like it feels like you're not playing with objects, but you are. But let's not worry about that right now. But yeah, object-oriented is very popular. And then languages where you kind of have a choice, like, well, do I want to use objects right now or not? Like Python, really popular. Good question, though. Yeah. So yeah, the warning at this stage is, I'm going to introduce stuff to you. Some of it might not be very clear. Or maybe clear, but you're left scratching your head of like, but what's the point? Why? I don't know, like, what's going on here? Just sit tight, pay attention, and it'll hopefully come together really nicely. Sorry?
You're going to teach us the main part, and then you're going to teach us something else later that'll help us understand that part.
Kind of. Not, I wouldn't word it that way, but if that helps, whatever. All right, so now we need to write the constructor. I mean, we don't have to do this next, but to me it makes sense to write the constructor next. If I go ahead, so now I'm defining this class. And if I ever want to make an instance of this class, and I have this object created that I can manipulate and use later for whatever reason I need, if I'm doing this, do I want it to be set up on creation with any special things already kind of configured? So here is the start of writing. Let me unindent this. Nope. There. Writing my constructor. Again, there's nothing currently in here except the comments. In fact, I'm going to delete the comments just for fitting it on the screen nicely. You'll notice there's a couple of really funny, weird things here. Now, before I keep going, let me go on and just say, so def init self followed by however many parameters we want. It's just a function, and I can have as many parameters for the constructor I want. And what I had up there is no parameter, kind of. You'll see self, and self is interesting. I'll talk about self in a moment. But other than self, there's no additional parameters I've got in my constructor so far. But I can have however many I want. But your constructor has to have the name underscore underscore init underscore underscore. That is a very special name for it's a special thing for Python that means constructor. If you don't make it underscore underscore init underscore underscore, it's not a constructor. So it's got a very special name. It's a reserved name for that specific class's constructor. Now you might say, what if I'm making two different classes? Well, they would both have their own init, but the inits are within the class, so they don't conflict. So you'll see, okay, self is a funny one. This is a really good example of something that you're going to be like, that's so dumb. That eventually will be like, no, that makes perfect sense. I love it. Self is a reference to itself, which sounds very strange, right? Like, if I have a list, said my list equals, brackets. My list is a thing that, it's a reference to a list somewhere in RAM. Self is going to be a reference to itself. Just keep that in your brain and it'll come up in a moment. We can use self as a way to say something about myself. In other languages, so by the way, it doesn't need to be called self, but it needs to be called self by convention. If you don't call it self, it'll be mad at you. But the first parameter in all of your functions, of all your methods that are part of that class, they got to start with self as the parameter. You could call it Bob and replace all the selves with Bob, but every other programmer in the world is going to hate you, so don't do that. In other programming languages, this concept exists, but it might be called something different. Like in Java, it's called this. This is the pointer to itself. This is me.
This is this.
Yeah, this is this. So it's like, I am a human. And I can ask another human, you, what's your first name?
AJ.
What's your first name?
Riley.
What's your first name?
Aiden.
What's my first name? Well, it's James. But it would be like self first name. Okay? Just go with me, all right? So let's make our constructor more interesting. Nope. All right. So there. Can you still see that reasonably well at the back? Yeah? Cool. I'm going to run this. Oh, indentation error. Of course there's an indentation error. Let's try that again. There we go. Now it's happy. Now it actually runs and it's fine. And I can actually go and start creating enthusiastic student objects. But what do I have here? Well, def underscore underscore init underscore underscore, so it's the constructor, open parenthesis, self, followed by 1, 2, 3, 4 parameters. First name, last name, student number, and current average. Who here remembers what happens when you put equals some value in the parameter list? One person remembers. 2 people remember. Not many people remember, but that's not good. It's not that big of a deal, but it's basically a default value. If I ever call this function without specifying the parameters, it's going to assume, well, first name's John, last name's Doe, student number, current average, those things. So there we go. First name, last name. So the idea here would be I could make an enthusiastic student object and specify what their first name, last name, current average is, and everything. I can do that. It's pretty handy. In fact, I'm going to do that right now. I can now that this is run, let's open up another block here. Equals enthusiastic student. What should their first name be? Tom. What's their last name?
Thomas.
Us? I just like us. Tom Thomas. Let's go with Tom us. Their student number will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And their current average is 43. Tom us needs to get his act together. And I'm going to make another student, student B. Enthusiastic student. What should their first name be? Liam? Last name. This is not the hard part of the lecture, guys. Carter? Student number 09870. And what's their average? 12. Oof, Liam Carter. No, I hope there's no Liam Carter in here. Then let's make one last student. Okay, what's their first name? Carson? Why? Now well, I'm going to go with Carson. And then Avery, is that spelled right?
Yeah.
Carson Avery, because why not? And their student number is 6. Oh. There we go. And what's Carson Avery's average? 80 something?
I was going to say 7 and then my tongue got tied.
All right, well, let's go with 87. All All right, great. I'm going to hit run. Okay, it all worked. You know what? I'm going to make one last student. Student D equals enthusiastic student, and I won't give it any values. Great. I have now created 4 enthusiastic student objects. I have 4 instances of an enthusiastic student. They are all enthusiastic students. They all follow the class definition up there. They all follow this. There's not much happening here. This is a very, 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 very simple class. All it does is store their first name, last name, student number, and their current average. We could make it do more if we wanted. I'm just keeping it simple. So, they're now created. I'll just go down another cell. Student A dot first name. Any idea what's going to be printed out when I hit run? Tom. Why? Well, that's student A's first name. What about student B? Liam. Student C? And then the real test? John, because it just followed the default values. So at this stage, all I'm doing is, creating an instance and then storing basically just 4 attributes. Their first name, last name, student number, and current average. That's all. Not much happening, but that's all. I could make an enthusiastic student object for each and every individual one of you. And then if I ever wanted to know what your current average is, okay, great, I can just go check it in the object. I could say, well, what's student D's current average? Oh boy, not very good. So, there. Any questions up until now? I'm expecting questions, so it'll be weird if people don't ask. Yes?
I was just wondering, basically, when you did the first one, you said basically source and then name. If you took away the name part of the individual, you kind of understand what I mean? Would it make a difference?
I think I know what you mean. Yes. So you mean like, wait, say that question again?
Like, when you had it as source and then you had the underscore name at the end after, dot B or A or whatever. If you took away just the name part from it.
Like this?
Yeah, like that.
But I like what you're thinking, right? Because we can create variables, whatever we want, right? But here we're accessing a parameter, a variable, that belongs to a specific instance, that has a name. The variable has a name, or a label. But current doesn't exist. And we see the error, object has no attribute current, which is correct. It's current average. And by the way, notice what Colab is doing here for me. And if you're using PyCharm or Spider, it's going to do the same thing. Like, if I go down and create a NumPy, and I say my NumPy array dot, you see that list pop up. I wrote my own enthusiastic student. Before I hit run on this, Colab had no idea what an enthusiastic student is. It didn't know. I had to define it. Now that it's defined, look, it knows. It knows what attributes belong to that class, which is pretty awesome. So it knows if the object created is an enthusiastic student object, it must have a value for current average, first name, last name, and student number. It must. Yeah?
So when we're giving, say, student C, their, characteristics, if we give, the average, it wants an integer, could we give it, a string, and would it still work?
So this is a funny issue with Python. Python's great. It lets you mix and match types all the time. Great, freedom. Because I could say 43 and it'll work, but it shouldn't be, right? So there are a couple of ways to address this as a programmer. The most common and best one is something called like type hints, where you basically you tell Python like, okay, you're going to get something called current average, and it's got to be an integer. And then if someone tries to do it like I just did, it'll go, no, that has to be an integer, right? A lot of other languages kind of do this like implicitly, just by how you have to do certain things. Everything has to have a type. Every variable, the value that it has to have that type. So Python doesn't. You can mix and match. You can change what this points to whenever we want. So type hints are a way around it. Another thing too is you can check in this code, like you can check like, does first name contain only letters? Like you can do all these checks in the code if we want. Like we can also check like, is there a number in that name? Because if so, it's not a valid name. Stuff like that. Or maybe it is a valid name. Whatever. I don't know. Just we can do whatever checks we want in there. Good question though. Other questions? Yeah.
So what exactly is self-classified as? Because in it is like the thing that it does stuff, and then self is like an attribute?
Yes. Well, it's funny. Every object has a reference to itself. Now, let me put it this way. Down here, I was able to say student A dot current average. Okay? So I used student A, which is a reference to an individual, an object somewhere. Within this code, if I see how it says self, well, that's a reference to an object. It just so happens that it's self. So if I said, and by the way, I can change these attributes here. So I'm printing it out. Here, let's do this. Let's do student D, first name. If I do this, it's John. But I can do student D dot first name equals not John. Well, now it's not John. Like I created it as John, and I can change those attributes. Arguably, you shouldn't do it this way. This is bad, but whatever. You could totally do this. But notice that I'm accessing that variable, that parameter, through a reference to an individual object. The reference is student D. It's a reference to an individual object somewhere. But because we need that reference to the specific object we're setting that attribute for, the object needs to have a reference to itself. This might seem like, but I don't know, kind of like extra verbose, but it ends up being kind of handy, and we'll see an example of good use of it soon. But in other programming languages, like Java, you have this. But in Java, you don't need to specify this in front of it. It'll just assume. Where in Python, no, you got to specify. Yeah?
Why do you not have to write self when you're writing student A equals enthusiastic student?
Why I don't have to do like that?
No, in the last step.
Oh, right here? Because I'm not within the class.
Like in self 13.
Wait, what?
Like down 5 or 6.
Here?
Yeah, just somewhere. Like why don't we have to write self at the start?
Oh, I got you. Like why I didn't have to be like
Yeah.
student, like something like that? Because I don't. It's just within the class, it knows that, okay, there is this secret special first attribute that is a reference to itself. Yeah. These are good questions, though. Here, time we got. I'm going to show you, perhaps we're going to come back to this, but let's say I want to have a method that will tell me if two student objects are the same. Okay? Because it could be possible, maybe somehow I made an alias by accident. Maybe I made a copy of a student, and then I don't know. At this point, I might want to check. I might have some code where I want to check if two objects, two instances of an object, that might happen to be the same one, if they are considered equivalent. The question you ask yourself at this point is, well, what does it mean for two enthusiastic student objects to be the same? What would it take for them to be considered equivalent? Like if they're numbers, if they're integers, it's obvious, right? If they're the same thing, because that's how it's defined. We've been using these rules since we were this big. But we are now inventing this new object called an enthusiastic student. What does it mean for two enthusiastic student objects to be considered the same? If I had two list objects, what does it mean for them to be the same? Like that's defined somewhere. Here, I'm defining what it means for these two objects to be the same. And it looks like the way I'm doing it is checking if their student numbers are the same. Student numbers should be unique. So if they have the exact same student numbers, then those two student objects must be the same. That's how I'm defining it. If you do first and last name, well, that could work, but then again, it's also possible that two Bob Smiths have gone to St. FX, right? So we need something unique, so we'll use the student number. And if this particular enthusiastic student and this particular enthusiastic student happen to have the same student number, then they are equivalent. Are we okay with that statement? All right. Now, here is perhaps a good demonstration of self. So here's the function called EQ, and you'll notice it's underscore underscore EQ underscore underscore. This is another one of those special functions or methods. But we will hit this harder tomorrow. When do we have class next? Tomorrow? Yeah. Whenever it is next, yeah. I'll hit it harder then. But so within this class, I'm defining what it means to be someone's going to ask an instance of this object, are you equivalent to that one? That's the question. It's like I'm asking you, hey, I need you to check if you're the same as that one. Okay, that's what I'm doing. So I'm asking you. So you are part of the equation at this point. You are the thing being compared to something else. And I give you a reference to the other thing that I want you to compare to. So I say, okay, what's your student number and what's the other thing's student number? Imagine I just had something like this, like we've got a problem, right? How do I differentiate, whose student number? Because both enthusiastic students have a student number. When I look at the code like this, I go, okay, self-student number. That's my student number. That's your student number. That's the object I asked to compare to something else. That's their student number. And then you have to ask the other student, well, what's your student number? And then you can do the comparison. So this might kind of help make self make a little bit of sense. Does this help? Self is, well, whose student number? Well, it's my student number. So my student number. And then your student number, are they the same? That's the idea. If at this stage, though, you're saying, this is one of those things that, I'm going to be honest, when I started learning programming, it was in Java. And Java has this. Like, the keyword this is the same idea as self. I didn't really get it until, second year. It didn't really click for me. I was like, okay, fine, it's just the magic words I need to use in certain cases. Which is never a really good strategy for learning something. But the point is, if it doesn't click at this point, you're not crazy. It is a funny idea that an object has a reference to itself. It feels like, why does it need that? Shouldn't it just have it? Well, it doesn't. All right, so yeah, here's the We did that. So first name, attributes, I'm giving the objective. Okay, outside the class, type the following. Okay, well, we already did this. I spoiled this activity for you already. Oh, yeah, here's a good one. Let's run this again. Run this. Look at that. I asked, hey, what's the type of student A? And it tells me, oh, well, you know, it's an enthusiastic student. It tells me, it knows now. It has its own type, which is pretty cool. Let's not worry about it right now.
I'll ask it another time.
Yeah, ask it another time, because there is a long answer to that question that I don't want to talk about right now, because it's just going to confuse. It's later. Okay, what else? Create a new one, add a print statement saying I'm running. Oh, okay, here's one last thing I want to do before we go. So, when I wrote this line of code, when I said student A equals enthusiastic, when this line of code ran, it ran the code in the constructor. It did. And if you don't believe me, I'm going to prove it to you. There. I added a print to the constructor, meaning that if this function is called, it should also print something out. Right? How many times am I calling that constructor? 4. I ran. Great. Cool. So this constructor, this code is actually running. I'm going to get rid of that though, because it's kind of silly. But yeah. So not today, but next time we'll add a couple of attributes. And we could do like whatever we want. You got to remember. Like, look, I know when I say on the assignment, make a class to do this, and this. Okay, yeah, you got to do that. But in general, when you're making an object, can I make a method do this? Yes, do it. You can do whatever. You are now God. You are creating objects in your simulated universe. So you get to do whatever you want. You're inventing it. You want another attribute? You want an attribute eye color? Great, do it. Doesn't matter. You can do whatever you want. Any last questions? Okie dokie. See you later.